Hey guys, Thunder Math back with another video. Today we're going to be doing another calculus problem. So it asked, a silver dollar is dropped from the top of a building that is 1,347 feet tall. Use the position function below, that is right here, to determine, or A is to determine the position and velocity of functions for the coin. So so first thing we have to do is analyze this little function right here, which is the position function. And this little part right here is the initial velocity, and this part right here is the initial height or initial position. So the word problem gives us the position but not the initial velocity, so this is going to equal 0. That was an awful 0. And the position is going to equal 134.7. Okay, well, you get the point. So it would just be negative 16 t to the second plus 1347. That's our position function. And if we look at our little chart right here, we can see that taking the derivative of the position function gives us the velocity function, and taking the derivative of the velocity function gives us the acceleration function. However, we're not going to be talking about acceleration in this video. So let's find the derivative right here. We're just going to implement the chain rule. So for this first little thing, anything that doesn't have like a variable next to it will just go to 0, and then we can implement the chain rule here. So we multiply the power by the coefficient, and we'll get negative 32 t. I should not be using the mouse and keyboard to illustrate it, so we'll just try and do better here. And that's our velocity function. It's just the derivative of the position function. So next it asks us to determine the average velocity on the interval. So the way we do this is just to find the difference between the initial velocity of 4 and, or not the initial velocity, but the velocity at 4 and the velocity at 3. And we do this by plugging these two into the position function. So at 4, it should be like that. Here, let me illustrate this much better. Should be minus 16.4 to the second plus 347. We'll just put that whole thing in parentheses. Minus, same equation except 3. And what we get for that would be negative 112. Alright, so that's the average velocity during this interval. So to find the instantaneous velocities, which are different from the average velocities, we this time use the velocity function and just basically plug these two in. So v of 3 would equal, oh man, that's awful. I need to get a better system for drawing, because this is ugly. So v of 3 would be equal to negative 9.6, and v of 4 would be equal to negative 128. Alright, next one, it asks us to find the time required for the coin to reach the ground. So this time, since it's asking us for time again, we're going to use the position function. So negative 162. Alright, and since it's asking us the time for it to reach the coin, or the time for the coin to reach the ground, we know that at ground level the height would equal 0, so we'll just set the entire function to equal 0, and when we evaluate that we get 9.175. Let's write that better. 175. Alright, last question. It asks us to find the velocity of the coin at the impact. So how we do that is basically, we know that it takes, sorry, that's not negative. I don't know why I wrote it as negative. We take our time for it to reach the ground, which we evaluated in the question previous, and we basically plug that into our velocity function, so we can get the velocity of the coin from the time it impacted. So when we evaluate that, we should get negative 293, and we'll just say 612. So yeah, so that's how we do it. So remember to leave a like and subscribe and comment if you have any questions. I'm happy to answer any, and good luck on your next test. Thank you.